Good day, dear colleagues. For your attention, I want to present research on the optimal geometrical parameters of boreholes in dimension stone quarries. This slide shows you the main process of extraction of natural dimension stone, such as drilling, blasting, splitting, cutting, crushing, and excavation. All used methods for dimension stone block extraction can be divided into crack forming, split shaping, physical, technical, and combined methods. Still, the most common ones are crack forming and split shaping. One of these methods is shown on this slide. Extraction of natural stone blocks has a large amount of drilling. The quality of drilling operations determines the effectiveness of further operation for splitting blocks from the massive. Borehole deviation from the design position causes an increase in the volume of drilling operations due an increase in the rate of drilling boreholes. When using fracture forming methods, the deflection of boreholes axis causes a change in the geometry of splitting forces spreading, affecting the efficiency and quality of splitting and separation process. Borehole deviation, when performing drilling operation of stone massive, can cause increased separation area, tool costs, and poor quality of block production. The quality of drilling boreholes is determined by a number of indicators, such as mode parameters of drilling process, type of condition of drilling tools, state of rock mass. It's necessary to note that some factors like geological, technical, and technological impact on the deviation of borehole. Geological factors are encounter with the crack as stress state factors of the massive. Technical factors are a clearance due to physical tools wear, structural defects in the particular part of the drilling machine, and the last is technical factors such as inaccuracies in the installation of the perforator, influence of the surface roundness of which the machine is installed. One of the impact technological parameters of the extraction of granite blocks is the required distance between the holes that are drilled in the design splitting plane. For calculation of the distance between boreholes, it is proposed to use the equation that presented on the slide. The equation consists of such parameter as diameter of borehole length, pressure the watt of borehole, granite monolith height, ultimate rock tensile strength, a coefficient that takes into account the reduction of the strength of the stone from the time of loading. During the drilling of borehole line for splitting, in addition to the basic equations of the flat problem of elasticity theory, the plane of borehole displacement from its ideal location has to be considered. It means that the borehole has neither deviation in the azimuthal direction or in the circular direction. To determine the specific splitting area for one shim, uh, a dependence which takes into account both geometrical parameters of splitting and the anisotropic properties of natural stone, which makes it possible to use it in different deposits. For determining a specific splitting area, we can use the equation above. So in all other possible positions, the actual boreholes overlapping area will be below. As a result of field measurement, experimental values of the reduction and the weakened massive coefficient we obtained due to the deviation of holes from the design direction. As a result, the values of weakened coefficient were determined for different values of the directional angle and the vertical deviation angle. The graphic representation of this dependence is shown on slide. The above formula of technological loss coefficient allows to determine the coefficient of removal of blocks and the complex productivity of equipment for preparing blocks for extraction. In an ideal three-dimensional model of massive cracking, the geological coefficient of loss, since the main system of cracks are parallel with each other and their planes intersect at a right angle. Separate this three-dimensional model on the planes, the simple models of individual location crack system in the dimension stone massive. Considering the absence of ideal conditions of natural stone deposits, a non-orthogonal model was introduced, in which the basic system of crack do not intersect at a right angle. At the same time, it's considered that the angles of failing cracks in the massive are constant. That is, all the cracks of one system are parallel. Given all above, a three-dimensional model of fracture of an array was developed, which will allow determining the most optimal direction of drilling operation with the subsequent minimal losses of minerals. This slide shows three-dimensional model of natural stone massive fracture, and dependencies determine areas of separation planes. The main conclusions are presented, which are boreholes have different values of deviation from vertical, which causes a decrease of the specific value of the splitting plane, which depends on the azimuthal and zenith angles of the whole axis along the designed split time. The most negative value of azimuthal angle are observed in a range from 72 to 90 degrees and the zenith angle from 0.75 to 1.4 degree. Thank you for your attention.